So guys, we'll start with the bamboo today. This particular topic will be which is there in the third unit in the BMC, and we are going to look at more of how bamboo is used there in the walls. So this video will take you through, and you can refer this PPT also, which I'm going to be sending, and from which you can do the assignments. So basically, the first intro, as we all know, bamboo is also, it's one among nature. So bamboo is a woody grass. So it comes from the family of grass itself. So grass, but in the sense how there are tough grasses and there are those loose grasses which are there. So bamboo comes in this particular tough grass kind of family, and their growth is like very fast, which we all know, and they grow even very taller. And yeah, they are capable of growing for 60 centimeter or more per day. So the rate or the pace of growth in which bamboo grows is like 60 centimeter per day. So 60 centimeter per day is close to 1 foot. So 1 foot per day, we can actually count them in some countries. Bamboo's thing goes up to really say 100 feet and above also. And the growth rate is dependent on local soil. So for the bamboo which we have in our particular region in India, we have bamboos, particularly when we say on the north, when we look into Nepal and Bhutan, we have the highest gross amount of bamboo which is being used in construction, because that place is abundant. It's got the bigger forms of bamboo, and the strongest forms are the families of bamboo, the species, and it is abundant there. It's a resource by itself. It's a local construction material, like how we have our laterite bricks there in Kerala, and our normal ash bricks and clay bricks here in our state. So this is how bamboo's particular introduction works out to be. So now if you look at this question about why bamboo is used for structural applications. Okay, now we will all have this particular question of why is bamboo even used, and why can't we still cling on with the rods and stuff like that? Why can't we you know why can't we keep using the reinforcement rods, or we can use only the sticks or the poles which we used like in the previous prehistoric period. Now these bamboos, they have their specific qualities or their specifications, or their uses also, which you could say, and they are even farther more superior than any material which appears in nature. So the first point is they have the highest strength to weight ratio. So what is high strength to weight ratio? High strength to weight ratio is you're probably going to put an extra amount of load for which the number or the column number which can't take in the weight. For example, in bamboo, you see, if you take a single standing pole, if you're going to put a little bit of more extra load which the pole can't take, obviously the pole is going to break. Now with bamboo, that is not the case. With bamboo, there's this word called flexibility, which the bamboo actually bends itself. The bamboo actually bends itself so that the amount of weight or the pressure which is there can be actually mitigated. Now, for example, these areas which we have, they are called as the seismic areas. Seismic areas are areas which are prone to earthquakes. So there we can use bamboo, is what they're telling. In seismic areas, a complement to relatively non-rigid wall systems. So when we are looking at a straw and bale method of building a wall, straw and bale is one of the previous methods of building a wall. So to complement the problems faced in seismic areas of this particular you know excuse me. So bamboo is very friendly when used in construction in the seismic areas particularly. The next one is the strong fiber. So bamboo is composed of it is hollow inside, but the whole perimeter or the whole circumference of the bamboo material is composed of compressive strength. It is equal. The fiber is as equal to a compressive strength of concrete, and roughly same strength and weight ratio in tension also for concrete. So bamboo is kind of very close to concrete and steel. Now, uses of bamboo comes in residential and commercial building applications. So, bamboo is applied in wall systems, floor systems, and also in finishes. Now, use of bamboo in construction. Now, you'll have this question about where bamboo is actually getting used in construction. So, bamboo's particular method or the actual main natural use of constructions applies in these forms. So reinforcement is where we spoke about when we use a straw and bale kind of method. Reinforcement can be done with bamboo. So bamboo can be put in between the bricks as well as in between the mud mortar or things like that. So bamboo can be the reinforcement number itself. So reinforcement usually happens in a normal construction with rods. So rods which are of different sizes, 12 mm, 16 mm, 18 mm rods, and then we fill them with concrete for doing the columns. And for roofing, so most of us would have been coming through roofing of bamboo, because bamboo roofing, so bamboo's got this particular shape when you cut it out into which we'll see in the next slides. So bamboo will be actually showing good signs of water non-leakage. So the bamboo shape itself contributes to that particular thing. So if you cut the bamboo into half and you place on the roofs, the bamboo actually acts as the terrace tiles. In our place we would call those tiles as the terracotta tiles. Yes, the terracotta tiles. The in Tamil we call them wood. So that is a particular thing which the bamboo replaces. And in walling, so in walling, where do we use in walling? Because in walls, bamboos can be used very detailed in different formulas. So the next slides will show us how we are going to put bamboo on walls. And then there is the next one is the flooring, scaffolding. And bamboos do use in doors and windows, and also in decoration. So doors and windows, yes. If you can, I've already told you about googling a little bit of resorts and things like that where we can see bamboo. So this reinforcement detail of bamboo is what we did in the sheets. So our sheets actually in which we did a 2 by 2 connection structure, as well as a 3 by 3 connection structure. So the first one is what we did, the single post footing. Second was strip footing. So this is as usual as a concrete footing also. The names are the same, and the idea, the concepts are also the same, but the only material differs. So for example, if you see the single post footing, there is one number which is coming vertically on the x-axis and two numbers on the y-axis, and that number on the x-axis actually goes in deep. For example, let's say 1 feet or 2 feet inside, and that is concreted. Now, what happens in a strip footing is the strip footing, we've got this x-axis vertical number and horizontal y-axis two numbers. So what happens? These two objects, or these two numbers on the y-axis 1, which is y-axis 1 and y-axis 2, will actually rest on a little bit of a stripped footing. So in case the load is high, or this particular part of the site is not very good in soil, it might go down. So we use a strip footing, and we actually put it for reinforcement. So this is how reinforcement, bamboo is used in reinforcement. Now, bamboo foundations. So this is a very clear picture of how bamboo is used in foundations. Of course, it's not going to be on sand, but yes, it can be on sand when